This is going to be lesson number 7, and it's going to be entitled Factoring. This is found on page number 4. There's just a minor mistake. Just cross out the title and put factoring. And what factoring means is that we're going to factor out a number out of each term of the polynomial. So basically, when I look at 49x and minus 35, I ask myself, what can I factor from 49 and from 35? Well, the only number that goes into 49 and 35 other than 1 would be 7. So that means I can factor out a 7. Can I factor out an x? No, I can't, because the x only happens on the first term, and there's no x on the second term. To be able to factor, I have to factor from both terms. Okay? So the only thing I can factor is a 7. So now I open parentheses. And now I'm going to perform division. 49x divided by 7 is 7x. And negative 35 divided by 7 is negative 5. The cool thing about factoring is that once you have your answer, if you multiply it back in, you should get the original problem, such as 7 times 7x is 49x, which is our first term, and then 7 times negative 5 is negative 35, like our second term here. So you can see that we did the factorization correctly. The next problem. Is there a number that goes into 5 and 2 other than 1? The answer is no. Can I factor out an x? No, because the x only happens on one of the terms. So that means this would be a prime. It would be prime. Okay. Alright, let's move on to the next one. The next one, I noticed that they both have z's, so that means I can factor out a z. Now, how many z's the first term has? The first term has 3 z's. And how about the second term? The second term has 2 z's. So if I remember that factoring, I need to factor the same amount from each term, then the right amount would be 2, because when I factor out 2 from here, this guy has enough to factor out 2, and so does this one. So in other words, to figure out the number of z's that you can factor out, just look for the smallest exponent, and that will be the thing that you're going to factor out. Alright, now we're going to use those properties of exponents that we learned. Basically, we're going to do this mentally, but I'm just going to write here on the side what basically is going on our minds, okay? We're going to be doing some mental math right now, but just reminding some of the properties that we're doing. Basically, what we're doing is we're taking z to the third right here, and we're going to divide by what are we factoring? We're factoring by z squared. So z to the third, z squared. What do I do? Excuse me. What do I do with the exponents? Well, this would be 3 minus 2 would be 1. Okay, so it'd be z to the first. Same thing. If I take negative z squared and I divide by what I'm factoring, what is z squared, negative z squared divided by z squared, the z squared cancels. Remember, there's an invisible 1, so what I'm left with? A negative 1. So this would be z squared divided by z squared is negative 1. Okay? So let me retrace my steps here. Here I see I have z's on both terms, so I decided to factor out a z. Well, how many z's? You look for the smallest exponents. Small exponent is 2. Z to the third divided by z squared is z. Z squared divided by z squared is 1. Alright, let's go to the next problem. What can I factor from 3, 15, and 9? The answer would be 3. Can I factor out an x? Yes, I can, because the x occurs in every term. Well, how many x's can I factor? Look for the smallest exponent. Smallest exponent is a 2. Once you decided what you're going to factor, go ahead and open your parentheses. Now do the division. 3 divided by 3 is 1. X to the 4th divided by x squared is x squared. Negative 15 divided by 3 is negative 5. And x cubed divided by x squared would be x. And positive 9 divided by 3 is positive 3. And x squared divided by x squared, the x squared cancels. So this would be my final answer for this problem here. Alright, let's proceed and do the next problem. Okay, what can I factor from 12, 10, and 2? Answer would be a 2. Can I factor out a b? Yes, I can. The b occurs in every one of them. How many b's can I factor? The smallest exponent is a 1, so I'll factor 1. Also, on this problem, we usually don't like to have the first number to be a negative number. So in other words, to force the negative out, I'm going to factor out a negative. And by doing that, when I open that parenthesis, the first number here is going to be positive. Take a look. Negative 12 divided by negative 2 is positive 6. B cubed divided by the b will be b squared. Positive 10 divided by the negative 2 will be negative 5. B squared divided by b would be just b, or b to the first. And the last one, negative 2b divided by negative 2b is positive 1. And that's our factorization here. Okay, so let's go ahead and turn the page to page number 6. So let me move my paper. Alright, we are on top of page number 6. Oops, sorry. Alright. And basically we ask ourselves, what numbers can I factor from 18, 9, and 27? And the answer would be, I can factor out a 3. How about an x? Can I factor out an x? Yes, I can factor out an x. And it would be only 1 because there's only power of 1 here. How about an I? The smallest exponent for y is 3. So that's all I can factor. So now let's proceed into the division. 18 divided by 3 is 6. X divided by x, the x cancel. Y to the 5th divided by y to the 3rd gives me y squared. Now we'll go to the second term. 9 divided by 3 is 3. The x will cancel. And the y to the 4th divided by y to the 3rd is y to the 1st. Now the last term. 27 divided by 3 is 27. The x divided by x will cancel. Y to the 3rd divided by y to the 3rd cancels. So in other words, we're left only with 27 by itself. Alright, next example. What number goes into 8, 20, and 27? There's no number that goes into all three except for 1. Alright, how about an a? Can we factor out an a? Yes, we can. Well, how many? Well, just 1, because the smallest exponent is 1. How about b? We can factor out how many b's? We can factor out 3. Now that we decided what we're going to factor, let's go ahead and proceed. 8 divided by invisible 1 is 8. A squared divided by a is a. B to the 4th divided by b to the 3rd is b. Negative 20 divided by the invisible 1 is negative 20. A cubed divided by a would be a squared. B cubed divided by b cubed, the b's cancel, so I'm just left with this. And then the last term would be 27 divided by 1 is 27. And the a's would cancel, and the b would cancel also. So that will be my final answer for letter G. Alright. And okay, now what you can do is stop the video, and you can do the assignments 7A or part 1, okay, of the assignment that has to do with these kind of problems. Once you've done that, you're welcome to restart and do the second part, which will deal with part 2 of the assignment 7. Okay? Okay, welcome back. This is part 2, example 7.2. And basically, on the problems before, we talked about factoring problems like these. And like this would be a trinomial because it has 3 terms. When I look at this problem here, how many terms does this guy has? Well, this guy has 2 terms. Okay? And what do these 2 terms have in common? Well, they have in common y minus 1. So that's what I'm going to factor. I'm going to factor a y minus 1. Remember, factoring is like taking out. You're taking out y minus 1 from the first term and y minus 1 from the second term. So if we take out the y minus 1 from the first term, what is left on the first term? If I remove the y minus 1, what is left? Well, I'll be left with only x. And if I remove the y minus 1 from the second term, what am I left on the second term? Well, negative 13. So in other words, this is what was removed, and this is what remains after I remove the y minus 1. So that's my factorization there. Alright, let's try the next one. We notice here we have a negative minus a parenthesis here. Remember, anytime you see a negative in front of parentheses, you can always put a 1 in front of it. So there's an invisible 1. That we want to make sure that we remember that there is a 1 there. Now notice that there's 2 terms, and what do they have in common? They have in common 2m plus n, and if I factor that out or remove those 2m plus n, what am I left with? Well, in the first term I'll be left with 5m squared, and if I remove 2m plus n from the second term, I'll be left with negative 1. And that's my factorization for this part B. Alright, very well. Let's continue to problem number letter C. I asked myself, can I factor anything from all 4 terms? And the answer is no. So here's what we're going to learn today. We're going to learn something about called grouping. We're going to group this into pairs. And we're going to just focus our attention on the first pair. We're going to ask yourself, what can I factor from the first 2 terms? Well, I can factor out an a. And if I factor out an a, ab divided by a is b. 4a divided by a is 4. Okay, so I'm done with the first 2. Now I'm going to bring down that positive that's in the middle. I'm going to ask myself, what number can I factor from 7b and 28? And the answer is 7. And if I factor out 7b divided by 7, I'll get b. And then 28 divided by 7 gives me 4. Now would you look at that? By doing this, I have now two terms. What do they have in common? They have in common b plus 4. And if I remove the b plus 4 from the first term, what I'm left with? I'm left with a. And if I remove b plus 4 from the second term, what I'm left with? I'm left with the 7. And that is my answer for this problem. I was able to factor this into this. Let's try the next problem. Again, ask yourself, can I factor anything from all four? And the answer is no. But if I try to group them into pairs and ask myself, what can I factor from the first two? I can see that I can factor an x. And if I factor out an x, 3x squared divided by x becomes 3x. 4xy divided by x becomes 4y. Now, if I bring down the positive, if I look at the next two terms, what can I factor from 3x and 4y? Nothing really except for 1. So in this case, we're going to factor the 1. And 3x divided by 1 is 3x. And 4y divided by 1 is 4y. Now that I have that, what do they have in common? They have in common 3x plus 4y. And if I remove what they have in common, what's left? The x plus 1. So that will be my answer for this factorization. Alright, let's continue to the next example. Alright, again, can I factor anything from all four? Answer is no. So I'm going to group them. What can I factor from the first two? I can factor out an x. 3xy divided by x is 3y. X divided by x is 1. Bring down the negative. What can I factor from 12y and negative 4? A 4. Now, negative 12y divided by negative 4 is 3y. And negative 4 divided by negative 4 is positive 1. Again, what do they have in common? 3y plus 1, x minus 4. Very well. Alright, let's try letter G. Can I factor anything from all four? The answer is no. So, let's group them into twos. What can I factor from the first two? Can factor out a 2. 2x divided by 2 is x. Negative 2 divided by 2 is negative 1. Bring down the positive. What can I factor from the last two? Can factor out an x. How many x's? The smallest exponent is 2, so I can factor out an x to the second. X to the third divided by x squared is x. And negative x squared divided by x squared is negative 1. Again, what do they have in common? X minus 1. And if I remove the x minus 1, what is left? 2 plus x squared. And that's my answer. Okay. Alright, here's on the last example. Again, always ask yourself, what can I factor from all four terms? Well, in this case, we can actually factor something from all four terms. And what we can factor is a 5. 15xz divided by 5 is 3xz. 15yz divided by 5 is 3yz. Negative 5xy divided by 5 is negative xy. And negative 5y squared divided by 5 is negative y squared. So I was able to factor out of 5. Now let's look inside. Can I factor anything by grouping? If I group the first two and the last two? Well, let's take a look. What can I factor from the first two? I can factor out a 3 and a z. And 3 divided by 3 is a 1. X stays. The z cancels. 3 divided by 3 is 1. The y stays. And the z cancels. On the last two, bring down the negative. What can I factor from these two? Answer is a y. Negative xy divided by negative y is x. Negative y squared divided by negative y is positive y. And would you look at that? I have the 5 that is outside. Inside the bracket, what do I have in common? They have in common x plus y. And what's left if I remove the x plus y? 3z minus y. And that will be my answer. You cannot forget that 5 that you took out. Okay? Alright. Now, I'd like to show you something that happens often. So, I'm just going to copy real quick problem number 15 right here on the bottom. So let me move it up. So, not problem 15, problem H. So this would be 15xz plus 15yz minus 5xy minus 5y squared. Okay. Remember that first thing I ask is, what can I factor from all four? Well, let's suppose I forgot to ask that question to myself. Okay. And let's suppose I just went ahead and I just grouped them. Would I get the same answer? Well, I look at the first two. What can I factor? I can factor out of 15z. So 15xz divided by 15z is x. 15yz divided by 15z is y. Bring down the negative. What can I factor from the last two? I can factor out of 5y. 5xy divided by negative 5y equals an x. Negative 5y squared divided by negative 5y becomes a positive y. Alright, so now, what do they have in common? They have in common x plus y. And what is left over? 15z minus 5y. Alright, let me zoom out so you can see a better view. Okay, let me zoom out a little bit more. Alright. Okay. So here we have the same problem side by side. Okay. And basically on this one I factor out the 5. And my answer was 5 times x plus y, 3z minus y. Over here, I forgot to factor out the 5. And my answer was x plus y times 15z minus 5y. As you can see, I have different answers. The reason why I have different answers is because, see this 5 right here? This 5 is inside here. Because basically you ask yourself, can I factor anything from these two guys? No. How about from this guy? Can I factor anything? And yes, I can factor out of 5. So basically, I can factor out the 5. So this would be 3z minus y. And if you notice now, I have 3 terms, and I have 3 terms, and they're the same. So my recommendation is always ask yourself, is there any number that can factor from all 4? Okay, and always double check your final answer. Can I factor anything else from my answer? Because let's say, for example, here you forgot to factor out the 5. If you ask when you get the answer, can I factor anything from this guy? Can I factor anything from this guy? You're probably going to find out that you can factor out a 5. Okay, so this concludes the lesson number 7, and now you can complete the assignment 7 part 1 and part 2. And thank you very much for your time, and have a great day.